Okay, picture this scenario. It's Thursday night, late,
Mm-hmm.
11:47 p.m. to be exact. You've just closed your laptop, you're ready to wind down,
Mm-hmm.
maybe brushing your teeth, thinking about the weekend,
And then you hear it.
and then you hear it. That specific notification sound. A Slack message pops up on your phone.
Oh, yeah. The sound every engineer has like a Pavlovian response to. It just creates that instant spike of adrenaline.
Exactly. And it's a message that just drops your stomach through the floor. It reads, "Production database is gone, restoring from backup."
See, that is the moment of panic. But for the team in this case study we're covering today, that panic was actually pretty short-lived.
Yeah, at least at first.
At least at first, right.
Right, because they thought they were bulletproof. I mean, they weren't flying by the seat of their pants here. They had what looked like the Fort Knox of data safety.
Hmm.
They had 7 days of daily snapshots. They had automated backups from Amazon RDS. S3 versioning was enabled. They even had manual dumps running every single night as a failsafe.
On paper, they were doing everything right. If you were an auditor just looking at their infrastructure diagram, you'd give them an A+.
Oh, for sure.
You'd look at that redundancy and think, okay, the automated systems will handle this. Go back to sleep.
You would.
Yeah.
But fast forward 3 hours. It is now 3:22 a.m. The mood has shifted from, annoyed to catastrophic.
Yeah.
The narrator of our source material describes staring at a screen and realizing that they are, and I'm quoting directly here, fucked.
Because every single one of those safety nets had failed. All of them. Simultaneously.
7 days of snapshots, corrupted, the manual backups, empty, the automated system, broken. They were looking at a total loss of business data.
And that is the nightmare we are dismantling today. We're looking at a case study called We Had Backups, They Were All Corrupted. But our mission isn't just to, gawk at the disaster. We need to dismantle a really dangerous assumption in the tech world.
Which is?
The idea that just having a backup means you are safe.
It is a semantic trap, really, because as we're about to learn, a backup is just a file. A restore is a capability, and they are not the same thing.
Precisely. We're going to break down how this company lost 18 hours of critical data, thousands of customer records, and tens of thousands of dollars in unreconciled transactions, all while following best practices.
So let's open up the autopsy report, because when we say disaster, sometimes that feels abstract. But here, we have a literal damage report. What did this actually cost them?
The numbers are brutal. When the dust finally settled, they had lost over 4,000 customer records.
Wow.
That's 4,000 people whose accounts or their history or pending orders just vanished into the ether.
And financially.
They had $67,000 in failed transactions.
And that's not just lost revenue, right?
Yeah.
That's unreconciled money. That's the worst kind of money problem.
Right. That's money that's effectively in limbo. The bank says it moved, your database says it didn't. That is a nightmare for the finance team that lasts for months.
You have customers calling saying, "I paid you," and your system is saying, "No, you didn't."
It erodes trust instantly.
Okay, so the stakes are massive. But I want to get into the how. We listed 3 different ways they were backing up their data.
Yeah.
How is it statistically possible for 3 independent systems to fail at the exact same moment?
Yeah.
It feels like lightning striking the same spot 3 times.
That is the fascinating part. It wasn't one giant failure. It was a cascade of 3 specific independent failures that just happened to align. Let's start with system 1. The RDS automated snapshots.
Which is usually the set it and forget it gold standard, right?
Yeah.
Amazon just takes a picture of your hard drive.
Usually, yes. But here's the technical catch. The most recent snapshot, the one taken right when the trouble started, captured the database mid-crash.
Mid-crash. But doesn't AWS handle consistency?
To a degree. But imagine taking a panoramic photo of a building exactly as the demolition charges go off.
Okay.
The photo exists, the file is there, but you can't use it to rebuild the building because the structure in the image is literally falling apart. The database was in the middle of writing data to the disk when it died, so the snapshot contained a corrupted file structure. It was technically there, but the database engine couldn't mount it. It was a picture of a disaster, not a picture of the data.
Okay, so the live snapshot is a bust because it captured a dying patient. But what about System 2? They had these manual dumps. They were running a script to save the data to a text file that shouldn't care about the disk data as much, right?
The manual dumps fell victim to a completely different problem. They were truncated.
Cut off.
Exactly. Imagine you are photocopying a 500-page novel, but the copier jams at page 250.
Right.
You have the beginning, the create table statements, the user list, but the ending, where all the recent orders and the transaction logs are, it's just not there.
So they had half a database, which is basically useless if you need the recent data.
Less than half in some cases. Which brings us to System 3, the wall archives.
WAL stands for write ahead log. For,
Yeah.
for those listening who aren't database administrators, how should we visualize that?
Think of the wall as a receipt tape. Every single time someone buys something or changes their password or updates a profile, the database prints a line on this tape.
Mm-hmm.
User A bought item B. And technically, these files were fine. They were valid.
So if they had the receipt tape, why couldn't they just rebuild the ledger? I mean, if you have every transaction, can't you just replay them?
You can, but only if you have a starting point. A receipt tape is useless if you don't know the starting balance.
Uh-huh.
You need a valid base backup, a solid foundation to apply those receipts to. And since their snapshots were corrupt and their manual dumps were cut off, they had a pile of valid receipts but no ledger to stick them into.
That is terrifying. It's like having the directions to a treasure map, but no map to start from.
Exactly. You're holding all the changes, but you have nothing to change.
But we have to back up a step. We're talking about the crash that killed the snapshot. What killed the database in the first place? Was this a hacker? A hardware failure?
No, and this is almost tragic in its simplicity. It wasn't some sophisticated attack. It wasn't Amazon Web Services having an outage.
What was it?
It was an kill.
Out of memory.
Correct. Someone, likely a developer trying to run a report or check something, deployed a batch job, and this job had a query in it that was, well, let's call it optimistic.
How optimistic are we talking?
It was a select from orders query.
Oh, no.
Yeah. That means give me every single column of every single row. And they didn't put a limit on it.
Oh, wow.
They tried to load 47 million rows of data into memory all at once.
27 million rows. That's not a query. That's a denial of service attack on yourself.
Basically, the server ran out of RAM instantly. Now, when a Linux server runs out of memory, it enters this kind of survival mode. It invokes the killer.
Which sounds like a slasher movie villain.
And it acts like one. It is the kernel's bouncer. It looks at the crowded club. Your server realizes it's overcapacity, finds the biggest guy in the room.
And kicks him out.
And kicks him out. In this case, the process taking up the most memory was the database itself.
So the operating system murdered the database to save the server.
Immediately. Sick kill. No saving, no graceful shutdown, just kill.
And because that happened exactly when the automated backup was running, the backup captured the murder scene, not the data.
Exactly. That explains the current failure. But here is where the story gets really twisted.
Right, because I'm thinking, okay, the database crashed tonight, so the backup from 5 minutes ago is bad. But what about yesterday or the day before? They had 7 days of retention. Why couldn't they just roll back 24 hours? Sure, you lose a day of sales, but you keep the business.
That is exactly what the host asked himself. He thought, okay, we lost today's data. That hurts, but let's just restore yesterday's snapshot. And that is when they discovered the silent killer.
That sounds ominous.
It is the scariest part of this whole case study. They spun up the snapshot from yesterday. It restored. The lights came on. They could connect to the database. But when they tried to read the orders table, which is arguably the most important table in an e-commerce business, they got an error. Invalid page header in block 472189.
Invalid page header. Break that down for us. What does that actually mean?
It means the data on the physical hard drive was just garbled. It wasn't readable text or numbers anymore. It was just digital noise.
Right.
But here's the kicker. That corruption didn't happen during the big OM crash at 11:47 p.m.
Oh.
It had happened 2 days prior.
2 days ago. But the site was up. People were buying things. How can the database be corrupted if the site is working?
This is the insidious nature of silent corruption. There had been a smaller, unnoticed crash or a minor hardware blip 2 days earlier. It damaged a tiny specific part of the hard drive where the older orders were stored.
Like a scratch on a vinyl record.
Exactly. But the database engine is smart, or maybe dumb, depending on how you look at it. It only reads the parts of the disk you ask for. Since nobody was looking at those specific old orders, the database never touched that scratch. It just read around the bad spot.
So as long as nobody asked for the specific data in that specific bad block, the site kept working, and everyone assumed the system was healthy.
Yes. It's like having a book with one page glued together. As long as nobody tries to read page 142, you think the book is perfect. You can read page 1, page 200, page 300. Everything seems fine.
Because they were taking snapshots of the disk, They were just photocopying the glued-together page every single night.
Yes. Snapshot number 3, snapshot number 4, snapshot number 5. They all contained this cumulative corruption. Every single backup in their 7-day retention window was poisonous.
Wow.
They were diligently backing up a broken file.
That is, I mean, that makes you want to go check your own backups right now. But hold on, we still have the manual dumps, the text files. You said they were truncated. Why? If the script ran every night, why was it cutting off halfway through?
This brings us to a really crucial lesson in coding scripts, the silent failure.
The source mentions a batch script.
Yeah.
It looks something like pgdump, gzipbackup.gz.
Right. It's a classic one-liner. You take the database dump command, gzip dump. You use the pipe symbol, that vertical bar, to feed it into the compression tool, gzip, and you save the result.
It looks elegant. Simple.
It is,
But
but the pipe symbol hides sins. When the database crashed mid-dump, the pjump command shouted, "Hey, I failed. Something is wrong." It exited with an error code, usually a 1.
okay, so the system should know it failed.
It should, but the script didn't stop because the output was being piped to gzip, and gzip looked at the incoming stream and saw it stop. It didn't know why it stopped, it just saw the end of the data. So gzip said, okay, stream's done, I'll just wrap up this file, put a nice bow on it, and close it. Gzip exited successfully with a code of 0.
So the script looked at the last command in the chain zip and thought, great job, team. Backup complete.
Exactly. It created a valid gzip file. It looked like a backup, it smelled like a backup, but when you unzipped it, half the data was missing.
Because they didn't have error handling that checked the first part of the pipe.
Correct. They ignored the exit status of the data creator and only listened to the data compressor. They created a system that was designed to give them false confidence.
Man, that is a subtle trap. Okay, so we have silent corruption in the snapshots and a bad script for the manual dumps. But the thing that really gets me is the testing. The source says they tested backups every month. They had a process.
This is what we call the illusion of testing. And honestly, this is the trap that 99% of companies fall into. I would bet most people listening fall into this.
Walk us through their test. What were they actually doing?
Okay, so once a month, they would spin up a new database instance. They'd restore the latest snapshot. Then they would run a simple query, select count. Basically, how many rows are in the orders table?
And if the number looked right?
If it was within 5% of the production database, they gave it a green check mark. Test passed.
I see the problem. Counting the rows doesn't mean reading the rows.
Bingo! Remember the book analogy? They were checking the page numbers. Page 1, page 2, up to page 300, okay? The book is all there.
They weren't reading the text.
Not at all. Select count often just looks at the index or the metadata. It doesn't necessarily scan the actual data blocks on the disk, so it didn't touch the corrupted block.
And the other flaw you mentioned, they always tested the newest backup.
Right. They never tested the backup from 5 days ago. If they had, they might have noticed that the corruption was traveling through time with them. They were testing the creation of the backup, not the validity of the restoration chain.
They were testing if the machine turned on, not if the data inside was alive.
Well said. Exactly.
So back to the timeline. It's 3:22 a.m. The automated snapshots are fried. The manual dumps are half empty. The wall logs are useless. The company is effectively dead in the water.
It's the moment where you start updating your LinkedIn profile. It's the moment you start drafting the "we are shutting down" email to your customers.
But then a hero emerges. And it's not the CTO. It's not the senior architect.
No, it is a junior engineer.
I love this part.
Yeah.
This is the shadow IP win. Tell us about the junior engineer.
So 6 months prior, this junior developer had gotten a little paranoid. Maybe he had trust issues, or maybe he was just really diligent. He didn't fully trust the opaque black box of the automated systems. So he wrote a personal script on his laptop.
Just on his own laptop. That sounds like a security violation in most companies.
It probably was. But in this case, it was the only thing that worked. His script did everything the enterprise system didn't. First, it ran the dump with proper error handling. If pgdump failed, the script failed.
Okay.
Second, it verified the dump using a command called pybrestore_list. It actually checked the table of contents of the file to make sure it was structurally sound.
Smart. Verification at the source.
And third, and this is the crucial detail, he kept 14 days of retention.
The company policy was only 7 days.
Exactly. The company policy was 7. He kept 14 because he was essentially hoarding data just in case.
So while the main servers were corrupted for the last 7 days,
He had a clean backup from 8 days ago sitting in a private S3 bucket that nobody else knew about. They found his backup. It predated the silent corruption. They restored it. They lost 8 days of data, which, don't get me wrong, is painful, but they didn't lose the entire business.
And I assume that junior engineer isn't a junior engineer anymore.
The source says he got promoted. And honestly, he should have been given a key to the city. He saved the company from complete extinction.
No kidding. So that's a close call. Too close. But we can't all rely on a paranoid junior dev with a laptop script. We need a better playbook.
We do. And the source material lays out a very clear new playbook for anyone managing data. It starts with a shift in mindset. Verification, not just creation.
What does that look like practically?
It means you don't just upload a file to the cloud and hope it works. The new script they implemented creates the backup, then immediately tries to load it into a temporary verification database. If that fails, it screams for help. It never uploads a broken file.
And for the bash script issue, that pipe problem.
There is a command, set UO pipe fail. It's a bit technical, but essentially it tells the script. If any part of this pipeline fails, even the first part, stop everything and report an error. It prevents that false success we saw with GUZIP.
Okay, that fixes the creation part. But what about the testing? We established that counting rows is useless.
Right. Real restore testing requires you to actually query the data. Don't just count the orders, pick 50 random order IDs and try to read them.
Right.
Check your foreign keys, make sure the order is actually linked to a user that exists.
And crucially, test the oldest backup.
Yes. This is the one people forget. Restore the backup from the end of your retention period. Ensure the whole chain is valid. If your 30-day-old backup works, your system is likely healthy. If you only test yesterday's, you might be carrying corruption forward.
There was one more idea in the solutions that I thought was kind of wild. The chaos backup test.
Oh, I love this one. It's extreme, but necessary. Once a quarter, unannounced, they delete the production database in a staging environment.
Delete it.
Go on. And then they tell the team, you have 2 hours to get this backup using our backups.
Talk about pressure.
It's the only way to know the truth. If it takes you 4 hours to figure out where the credentials are, or if the documentation is out of date, or if the restore script fails, you fail.
So the rule is what?
The rule is, if you can't restore in under 2 hours, your backups are considered useless.
That is a high bar, but after hearing this story, it feels like the only safe bar.
It's about moving from theoretical safety to proven safety. You need to know that your seatbelt works before the crash, not during it.
And finally, they added corruption detection, right? So they don't get hit by the silent killer again.
Yes. PostgreSQL has a tool called PG Verify checksums. It scans the physical disk blocks to ensure they aren't garbled. They run this regularly now. If a block goes bad, they know immediately, not 3 days later when the backups are already poisoned.
So let's unpack the big takeaway here. The source summarizes it perfectly. Backups succeed, but restores fail.
That is the mantra. You need to stop asking, do we have backups? And start asking, when was the last time we successfully restored the oldest backup we have?
And if the answer is, I don't know, or we just checked the row counts, you are sitting on a ticking time bomb.
You are. You're relying on a green check mark on a dashboard that might be lying to you.
You know, it really makes you think. We rely on these automated green check marks for so much. Your file is saved. Your upload is complete. Your system is healthy.
But unless you actually try to open that file or use that system in a crisis, you're operating on faith, not fact.
In this case, a massive enterprise-grade system with all the bells and whistles was beaten by a guy with a laptop who just didn't trust the machine.
Paranoia, properly applied, is a form of quality assurance.
I love that. So here's a question for you listening right now. What is the green check mark in your life, whether it's at work or your personal photos or your finances, that you're just assuming is safe? When was the last time you tried to do a restore on your own digital life?
It might be time to run your own chaos test.
Absolutely. Go check those hard drives. Thanks for diving in with us today.
Stay safe out there.